Hi guys, Sinan this side, and in this video we are going to discuss how to differentiate e to the power x square using the first principle. So the target for today is to find this d by dx e to the power x square. So basically, if you know chain rule, you know it is obviously 2 times x e to the power x square. But how do we actually get that using the first principle? So if we use the first principle, what we get is this limit h tends to 0, e to the power x plus h whole squared minus e to the power x squared over h, right? And somehow we need to solve this expression to get this. So let's basically do that. So I can just rewrite this as limit h tends to 0, e to the power x square plus h square plus 2 times h of x using the formula a plus b whole square is equal to a square plus b square plus 2ab, but you already know that. So anyways, minus e to the power x square over h. Now let's just use the laws of exponents to do this. This is equal to limit h tends to 0, e to the power x squared times e to the power h square plus 2 times h of x minus e to the power x square over h. So what this gives us is limit h tends to 0, and let's take out e to the x square, e to the power of x square common. So e to the power x square, e h squared plus 2hx minus 1 over h. Now if you see, e to the power x square is independent of this limit, so we can pull this outside. So what this gives us is e to the power x square limit of h tends to 0, e to the power h square plus 2hx minus 1 over h. Yep. So how do we do this? So let's say e to the power x square limit h tends to 0, and let's multiply and divide this expression by this number. So we can write this as e to the power h square plus 2 times h of x minus 1 divided by h square plus 2 times h of x, and this times h square plus 2 times plus 2 times h of x and over h. Fine. Now what I can do is just separate these limits to both of them. I can give a limit to this and as well as this expression. So what this gives us is again e to the power x square limit h tends to 0, and the same expression e to the power h square plus 2hx minus 1 over h square plus 2hx times limit h tends to 0, h square plus 2hx over h. So what this gives us is you can just cancel this h with this square and this h. And before that, let's say let's say alpha is equal to h square plus 2h of x. So if h goes to 0, so this term also goes to 0 and this term also goes to 0. This implies alpha also goes to 0. So I can just rewrite this above expression as e to the power x squared limit not h but alpha tends to 0, e to the power alpha minus 1 over alpha times limit h tends to 0, h plus 2 times x. Fine. And if you have seen my previous video, or if you have already done a limit course, you know this limit goes to 1, and since this expression is not an indeterminate form, we can just substitute the value of h as 0. What we get is e to the power x square times 1 times this 0 plus 2x, and this gives us e to the power x square times 2x, and which is now just rearranging the terms, 2x e to the power x square. So finally we actually got what we wanted. D by dx of e to the power x square is actually 2x e to the power x square by both chain rule and first principles. Yeah, that's it for the video. Thank you and bye.